Not like what?
What about a story?
Oh my God.
No, we need a story.
Quicker I get done with this, quicker I can do something like that. Yay. Yay, good. All right.
So no one has any questions?
No, there better be. All right, here we go. No mad dog eyes if someone asks a question. Let's see, page 71, 78 through 86. Was there any questions on 78 through 86? Remember, it's finding the center and the radius and graphing the circle.
You use 79.
79. Okay, problem number 79, you got x squared. X squared plus y squared is equal to 4. So x and y don't have a quantity they're squaring. So this means that our center is going to be at 0, 0. And the radius will be the square root of that, so my radius will be 2. So if you made an xy axis, your center's here. You're going to go 2 each direction from the center. And draw a circle. There it is. Other questions on page 71? Maybe? Anybody? All right, and then at page 542, I bet you most of these you guys need me to go over. Page 542, 9 through 12. Is it okay if I run through them all?
Yeah, sure.
Okay. Number 9, let me just write them all up. X squared plus y squared plus 6x squared minus, and then number 10. X squared plus y squared. Oh my gosh. Number 12. X squared plus y squared. 12 minus 8x minus 2y. Minus 19 equals 0. Okay. Woo! I think I got it right. You guys ready? Side conversations, hush. So starting on number 9. First way you want to approach these problems is you want to group the x's with the x's and the y's with the y's. You can't combine them together because you have an x squared with an x. They can't add together. And a y squared with a y, you can't add those together either. But you want to get them together. Once you get them together, you want to also create a space. Okay? So I'm going to do x squared plus 6x space y squared minus 2y space equals 6. Did you see the space between the blues and the reds? All right, let's complete the square on each. Remember, because I have an equal sign, I can, if I add to this side, I can add to this side. So I'm not going to add and subtract from the same side. I can add either side. So half of 6 is 3, and that squared is. So if I add 9 here, I add 9 over here. Is that okay so far? Okay, same thing with the y. What is half of negative 2? Negative 1. Negative 1 as a quantity squared is 1. So if I add 1, I also add 1 over here. Does that seem okay so far? So if I were to factor this, that's going to be the same thing as x plus 3 and x plus 3, or x plus 3 quantity squared. And this is my complete square over here. If I were to factor that, I would get y minus 1, y minus 1, or y minus 1 quantity squared. And then I can add all these up. So that looks like it's going to come out to 16. So my center to my circle is always going to be the opposite value. So I'm going to get negative 3, positive 1. My radius is always the square root of over there. So what's my radius? 4. If you were to graph this on an XY axis, so you got -3 and 1. And then from that point, I'm going to go, God bless you, 4 in each direction. So I got 1, 2, 3, and 4. I'm going to go 1, 2, 3, and 4. I'm going to go 1, 2, 3, and 4. And then 4 up. 1, 2, 3, and 4. Let's just pretend I can actually draw a circle. Pretty simple. So when you go through, make sure you combine your x and y's together, get them on the same side, create a space, complete the square. So let's see if we can walk through the next one. First step, let's get the x's and y's together. What else do I do on this step? Let's get the x's and the y's, the x's with the x's, the y's with the y's. What else should I do on this next step? Make a space, thank you. Okay, half of -4, -2, -2 squared, +4, add 4, add 4. Half of 2, 1 squared. This is my complete square. So if I factor that, it becomes x minus 2, which is the same thing as x minus 2 quantity squared, plus a complete square right here. It's going to be y plus 1, or y plus 1 quantity squared. Add this up, I'm going to get 9. What's my center? 2, -1. So 2, -1. Always opposite inside. Square root of the other side is the radius. 3. Make your xy axis. So I get 2, -1. And then in each direction, I'm going to go 3. So from the center, I'm going to go 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, and 3. There's your circle. Okay? Next one, get the x's together, get the y's together, and make a space. X squared plus 4x, space. Y squared minus 6y, space, equals, oh, what can I do with this? I can move it over so I have a 12 over here now. Is that okay? All right. Half of 4 is 2. 2 squared is 4. If I add 4 here, I add 4 over here. Half of -6 is -3. -3 squared is 9. If I add it over here, I'm going to add it over there. My complete square, that's the same thing as x plus 2 if factored, which is x plus 2 quantity squared. This right here is going to be y minus 3, or y minus 3 quantity squared. And then we'll add this up, so that's going to be 25. What's my center? -2, +3. Radius? So -2, 3. And then from that, I'm going to go 5 in all 3 directions. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Sorry about that. 1, 2, 3, 4, 5. Let's pretend I can connect the dot. Does anybody know what shape this becomes? This is extra credit, a million extra points. If that's a minus, an ellipse, hyperbola. It's going to be an ellipse. It'll be an ellipse. So, which is, remember, 2 things open in opposite directions or 2 things open in directions. The parabola, the other conic section of parabola, you would only have one of the terms being squared. And then the circle, obviously we know. And then an ellipse did what? It's a stretched out circle, right? Like an oval. Good. So that's still going to be a plus, but you're going to have a lead coefficient out in front of the squared term, which is a whole different way to get that. All right, combine like terms. Or bring them together, making the space. What should I do with this? What should I do with this? Add it, thank you. Okay, half of negative 8, negative 4. Negative 4 squared is positive 16. Half of negative 1, or negative 2 is negative 1. Negative 1 squared is 1. That should be 16. So this is my complete square here. So that's going to be x minus 4, which is x minus 4 quantity squared. This is going to be y minus 1, which is y minus 1 quantity squared, equals 35. Hey, Bob. 36. What is my center? 4, 1. Radius? 6. So go to 4, 1. And then what am I going to go in each direction? 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. How does that look? Okay. If I gave you a circle to look at on a graph, is it easy enough for you to identify the center?
Yeah.
And then how do you think you might find the radius if you're just not sure? If you knew where the center was, what would you do? Find the diameter. Good, I like that. So you just count across, or you can go from the center to the edge. And obviously going right or left in the horizontal direction, or up or down in the vertical direction, you just count, and that gets you the radius. And then what do you do with the radius to get over to here? What do I do? Yeah, you'd square it. Okay? What does it mean if a circle was, say, tangent to a line? What would that mean? What is, if something's tangent to something else? Huh? Touches it how many times? Once. Okay, so you might know that as tangent to a line. And I just want to give you this brief synopsis. You guys have been dealing with conic sections. We will deal more with them later in the semester. I think it sounds like some of you have heard of conic sections before. Do you know how a conic section is created? Has anyone ever seen that? I'm going to show you. It's not the most difficult thing on earth. Okay, I'm going to create a straight line. Still with me? Creating a straight line. I know it's angled, but it's still kind of straight, right? I'm going to basically hold 1 point constant on that line, and then I'm going to rotate the line around. This is called something called a nape, N-A-P-P-E. And how all of your conic sections are generated is like this. If you cut a perpendicular line, so here you had a line right here. Basically, if you cut a line perpendicular and took the cross section, this creates the circle, which we just did. You've also dealt with the parabola. The parabola is a line that comes in as either parallel to this line or parallel to this line. If it's parallel to this line or this line, it will cut the nape only once. So if you were to come down and create a line that's parallel, so these lines are now parallel to each other, this slices it. If you were to open up and look at the cross section, this creates your parabola, and that's why you have only one squared term with a parabola. Obviously, if you cut right at the nape, this creates a point. A point is not necessarily suggested as one of the conic sections. If you were to come along and make a slice that is parallel to this line, so this line is parallel to this line, this creates, it looks like two different parabolas, which would be an ellipse. And then, what was the last one? Oh, excuse me, not an ellipse, a hyperbola. So hyperbola. And then the last one is, if you cut the conic section with a line that is parallel or perpendicular to any of the other lines, so you have an oblique line, if you take a look at this, creates that oval, which is your ellipse. And that's how all of those are all generated. So you have to be able to sit there and say, okay, can I make this? There's a lot of teachers that might have shown you the cone and they take off the cross-sectional areas. The cone they're showing you is only one portion of it, but how the whole thing is generated is something called the nape. This kind of math actually pertains a lot to outer space. It has to do with how the planets rotate. It has so much to do. And the weird thing about this is if you do math, your geometry, using the nape rather than a rectangular coordinate system that you learned, you might remember from geometry, there's Euclid's 5 axioms. His 5 axioms work on everything you draw flat on a plane. Only 4 of the axioms work when you go on math on other objects that aren't planes. So if you did math on napes, all parallel lines intersect each other. So then you get into a whole different discussion. And this is actually a big part of the discussion of how would time work in any direction in this type of space. And this right here is actually how they kind of think that black holes kind of go a little bit. Hey, back for a little. Okay. So that's just kind of get you an idea. Now this is way beyond where the math is, but me and some of you might have seen the lunar eclipse yesterday. Just let you know, here's the kind of the application of the math, where some of this math would be used, would be in determining the lunar eclipse. It's kind of weird that there's people out there that can tell you when eclipses will happen, and they use this kind of math in order to determine it, which is, I think, is kind of cool. You know, is it really that practical to any of us? We're like, dude, I know when the next lunar eclipse is. Other than I'm going to get up way early in the morning and look at it. I don't know, or a solar eclipse as well. So, your assignment for tonight, which we will go over quickly tomorrow, is going to be page 71 through 78, page 72, 87 through 90, page 542, 1 through 6. I will tell you there is an assignment tomorrow, but I will make the assignment I give tomorrow due on Tuesday. Is that fair?
Yeah.
All right. We got like